How can we distinguish conscious and non-conscious behaviors using metacognition? Conscious and non-conscious behaviors, in summary, we can actually distinguish that. When we see things consciously, we can use that information for controlling subsequent behaviors based on the degree of confidence. On the other hand, that doesn't work for the non-conscious behavior. We cannot do that when our behavioral control happens non-consciously, like a reflex and so on. We because don't have a concept of the degree of confidence. You do that just no matter what. And so, here the idea is to employ a concept of metacognition, which is defined as an awareness and understanding of one's own thought process or things happening in the brain to distinguish conscious and non-conscious behaviors. So one hypothesis is that blindsight patient can take advantage of high performance in betting situation. So blindsight patient, as you saw in the last video, can perform actually 99% correct, well, 90% correct, say, for the seeing 99% contrast stimulus. However, they almost always say that, no, I didn't see it. And then the question is that if you actually able to use this, if you know how much you will be, how accurately you are, answering these kind of questions, then you can gain a lot of money. Then they might actually reveal the truth that they might have been just telling a lie, all the way. But that's the idea. And this is tested by this paradigm called the post-decision wagering. And importantly, this works for not only the patient, but also monkeys and also babies and many things, so that it can actually just test the social incentive kind of ideas that I mentioned in the last video here as well. So the idea is that after saying I saw or not, and then you ask people or monkey to bet something, let's say money or water or food or whatever. And then if correct, then obtain the double amount of the betted money. So it's simple, double kind of betting. So GY, the blindsight patient, was tested in this format, and then he was tested in 3 different conditions. One is at the super threshold for visible hemifield, like 0.2 condition. And then he is a relative blind side, so he can't see anything if it's low contrast, 0.2%, and 0.2 contrast. And then 0.96 super threshold contrast. In the case of GY, unlike HK, he says reliably, oh, I see it, and then I can locate that, confidently. So he was tested in 3 different conditions. Top and bottom is a conscious condition, and the second one is a blind side non-conscious condition. And here is the result. So first of all, the super threshold condition, he was correct in many of the cases. Then the performance, percentage of correct is roughly like 70% to 60 to 85%. So it's quite good. And then a percentage of the wager is also correspondingly high. So that means that when he is correct and he feels like he's confident, that he raised the bet and then gain as much money as he wants. However, in the case of the subthreshold stimulus, he cannot do that here, okay, because he cannot see it. Now, but this is a blindsight behavior, right? So performance-wise, it is actually correct, around 80% and so on, but percentage wagering, it's much lower than 50%. So he is not, really taking advantage of the correctness of the, trial. Now, so just to recap, that despite a good performance, GY did not bet high when he was correct in the case of the white subthreshold condition. So, however, as you learned in the signal detection theory, there is still a possibility of a criterion shift in betting depending on the visual field. So it may be the case that he's just, raising the bar to say yes on super high confident kind of trials, and then otherwise he just says no, 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 in terms of double betting. So to avoid this kind of a possibility, address the possibility of the criterion shift, what we can do is to apply the signal detection theory at the level of the metacognition. So here's an idea. Ruling out the criterion shift account with a type 2 signal detection analysis. Okay. So standard signal detection analysis is called a type 1 analysis. And then type 1 case, you have an observation interval where there is a signal or noise. And then after that, decision interval is the response of, oh, there was a signal or noise. And in the case of the type 2 analysis or type 2 task, the chunk up to here, stimulus presentation and your own response itself becomes the observation. So it is either correct or incorrect. Okay, so I'm shown the stimulus and then I say maybe right or left, and then either I'm either correct or incorrect. And then on that, your decision, you make a meta decision or a monitoring of the decision on this thing. So the response was either correct, therefore I will bet more money, or it was probably mistake, or I'm unsure, therefore I will not bet the money high. Okay, so that's the second order or meta decision. And then in this way, what you can do is to define hit and correct rejection as correct, like a signal detection, the standard signal detection type 1 analysis, and then define false alarm and miss as an incorrect interval, and then define the confidence response as high confident, or wagering response as yes response, and the low confidence or low wager as no response in type 1. And then when you do that, it becomes basically same as a type 1 analysis. And then, in other words, what we do is to interpret the task itself as, can we detect correct versus incorrect in ourselves? Can we monitor that accurately by high or low judgment in terms of confidence or wager? So let's see how it goes. This one is a bit complicated, but if we go through the actual task and the analysis, it becomes easier. All right. So then, first of all, this is a table 1 for the subthreshold stimuli in the scotoma, which means that it's a behavior of the GUI in the blind side hemifield. First of all, you observe that correct versus incorrect. There are lots of correct, fewer incorrect. So in terms of just a standard analysis, he is just correct more often than incorrect, and it's sort of the consistent with the idea that he is actually seeing things visibly. But according to his subjective experience, he says no, I don't see it. And the way to distinguish that is this type 2 signal detection analysis. Okay, and then the idea is that he should actually wager high when he's correct here, and then low or wager low when he's incorrect here. Just by looking at this, it's a bit complicated, and I'll go through it again. And then to interpret this in the signal detection theory in the type 2 analysis, I'll just have another slide. Okay, so in this format, first, the stimulus-wise, which you monitor, it's either present or correct trials, or absent or incorrect trials. And then all these numbers are the same thing. And then monitoring yourself makes some kind of response, type 2 response. And it's either present response or high wager in this case, or absent response or low wager in this case. And then all these analysis becomes again hit defined as a present stimulus and a present response, and absent stimulus and present response, that's a false alarm. And then remember that proportion of the hit and the false alarm with respect to all the response are the ones that are necessary to compute the receiver operating characteristic. So how does it work? Here, you need to compute the hit rate in type 2 sense. That is 67 divided by 101, and that's 0.48. And the type 2 false alarm is 23 divided by 59, and that's 0.39. Okay, now let's go back to the receiver operating characteristic. So type 2 hit rate was 0.48 and type 2 false alarm was 0.39. So we are going to draw the dot roughly 0.5 is here, so something around here for the false alarm. False alarm 0.39, and the hit is around here, right? And then if we plot that, it looks like this. It's a bit off, but more or less. And then on the other hand, type 1 analysis of the correct and incorrect using a false alarm and hit, that's this way, 0.71 and 0.29. Okay, and then this corresponds to type 1 analysis, and then this corresponds to highly accurate and conscious kind of processing. But in terms of metacognitive accuracy, it's almost close to chance, as a d prime of 0.50. So in summary, blindsight patient and monkey experience loss of phenomenal vision, according to their report and other types of evidence. But they show residual visual performance, behavior performance. And critical thing is that their information that supports such behaviors are metacognitively inaccessible. They cannot use that for the advantage of their behavior or maximizing reward. So now the question becomes, what brain mechanism explain the simultaneous existence of lack of phenomenology on one hand, and information that is either accessible or inaccessible to yourself? And to address this question, we need to understand the visual system much deeper. So far I've been scratching only the surface of the brain and visual system. So we need to go into a little bit deeper, and that's the next video.